Hi, this is Mrs. Vrobel. So in this video, we are going to work together about how to write ionic or covalent formulas from name. Sometimes that's a very challenging topic for students to figure out. Now on the left here, I have a reference that I included with the assignment, and it goes through a flow chart that you can use to figure out what kind of compound you have. Now, the nice thing is I broke up this assignment so you know whether it's covalent or ionic. But on a quiz, you might have to figure out whether it's ionic or covalent. So looking at the formula flow chart here, without determining whether or not it's ionic, we just want to look at, is there a metal? So metal or ammonium will tell us whether or not it is an ionic compound. And in this list on the right hand side here, there's no ammonium. However, there's sodium, there's iron, there's copper, there's barium, aluminum. Those are all metals. Okay, so notice that the first element name is a metal, and that tells us that it is ionic. So that's why in this worksheet here, we're essentially working on an ionic compound. Now I'm going to show you how to write the first name here. So notice that it is sodium and there's no Roman numeral. So we're essentially dealing with type 1 here. Type 1 is not a transition metal. Now the tricky part is for this first name here, bicarbonate, it is not a element that ends in IDE. So we need to look at a chart to figure out whether or not this is polyatomic. And if you look at the polyatomic ion chart, bicarbonate is there, okay? So that's a clue that we are not talking about a nonmetal by itself. We're talking about a polyatomic ion. So let's go back up to our flow chart here. So we have a type 1 and we use the group family charge on that metal. So I know that sodium, its element symbol is Na. And I also know that sodium is in the first column, which is group 1. Therefore, it's going to have a 1 plus charge. So I want to write 1 plus to symbolize the formula that we're eventually going to use. Now, the next thing is the nonmetal is, as I said, it is polyatomic. So since it's polyatomic, we need to go to the ion chart, and we're going to use the ion that is listed here. So it's HCO3, and it's a 1 minus. Now you have to be careful with polyatomic ions because they need a parentheses. So when we create the formula for this, we want to make sure that we put parentheses around it. And remember, crisscross, you bring down the number, not the charge. So when we do that, we end up with Na with an understood 1, HCO3. Okay, so that is using a formula with an ionic compound. Now I'm going to do a type 2 because I have a feeling that some of you are going to scratch your head about type 2. So type 2 compounds have a Roman numeral. So I'm going to jump down here to iron 3 chloride. So whenever you see a Roman numeral, that is going to be the charge of the metal. So I want to write Fe3 plus because of the Roman numeral 3. Now, chloride, so chlorine, it is actually found in group 17 which is the halogens, and that would be a 1- charge. Now, since the nonmetal is by itself, I don't need parentheses. I just need to bring down the number and not the charge. So when I write this formula, it's going to be Fe. There's going to be an understood 1 that comes from chlorine, and then I'm going to write Cl with a 3 to represent the number, not the charge, that is going to come down with that. Okay, so I want you to work on the rest of these ionic compounds, and you can feel free to contact me if you are stuck on any of these. Now let's go to let's go to covalent compounds. Covalent is probably the easiest to write formulas for because you are just looking at the prefix and then you're looking at the element name. So the very first one here on this page is disulfur tetrafluoride. So you need to memorize, and I told you this before we left, the different prefixes. So remember, mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, everybody knows octa, nona is 9, and then deca is 10. So you need to know all these different prefixes. Okay, so my letter A is disulfur tetrafluoride. So please remember, when you write the subscript, you want to write the symbol first, and then you're going to put a 2 there, and then fluorine has a 4 next to it. By the way, do not reduce. We do not reduce common multiples with covalent compounds. We do for ionic compounds, so you want to be careful with that. Okay, so I want you to go ahead and write the formulas for the following and submit your work, and then you want to double check with me and see how you did. Take care.